Okay, so there's several ways to use injected objects. And which way you use depends on the dependent object's lifetime that you need. And there are three different options. The first one is transient. And this is the option that is used by those couple custom dependency definitions within the startup class code that I've been showing you. So what this does is it maps the abstract types to concrete services that are instantiated separately for every object that requests it. This lifetime works best for lightweight stateless services. And like I said, this is the lifetime used by the auth message sender service in the standard ASP.NET Core project template. So if I request that particular class, that service, 20 times in 20 different objects in this application, there's going to be 20 different instances of that object floating around in memory. Of course, probably not all at once, but there's going to be one for each object that requests it. All right, then the second object is scoped. These objects are created once per HTTP request from the client browser. And that single instance is then shared during the lifetime of that request, no matter how many objects request them over the lifetime of the request. Okay, so if it's a very complicated process of responding to the specific request that you get from the client browser, then there'll only be a single instance of that dependency object, no matter how many objects injected into their constructor or their methods or whatever. All right, then the third option is singleton. Singleton objects are created the first time they're requested, or when configure services is run if you specify an instance there. And then every subsequent request will use that same instance across all application requests. You could always use the singleton pattern and manage the object's lifetime yourself, but it really is highly recommended that you let the dependency injection container manage it for you. Now, on top of these options, there are several ways to register services with the dependency injection container. You can register the service with a given type by specifying the type to use. Or you can use a factory that you can use to create the object on demand. You can also directly specify the instance of the type to use, in which case the container doesn't directly attempt to create that instance. Now, these three options for the lifetime of dependency injection are implemented through add methods, add star whatever. So it's add transient, add scoped, and add singleton. Okay, so let's take a little bit more in-depth look at how dependency injection works within ASP.NET Core. Here's a sample application that explores some of the features of dependency injection within .NET Core. This is a sample that I lightly adapted from a sample that Microsoft has made available. Okay, so I have this open in Visual Studio 2015, and that's because that was the version that it was built in. And I kind of know that it's using the Visual Studio 2015 because I have the project.json file rather than all of the configuration stuff within MS Build within the project file. No matter, release version Visual Studio 2015 works just fine. Okay, so I'm going to go ahead and run it to show you what the application does first. Okay, takes a little bit of time to start, but as you can see, there's a couple sections. One here will just display a page with various Star Wars character names. Okay, pretty simple. And then the other here is a page that you can use to explore the different lifetimes of dependency injection objects. Okay, so I'm first going to talk about the characters. Hopefully, if you're a Star Wars fan, those are familiar names. But let's go in after the application stops. Come on, shut down. Should do that automatically. Okay. And we'll go into the characters controller. So here's the index method. It's a regular MVC application. And what it does is this is the action method that's responsible for displaying the list of Star Wars characters. So it starts out by populating characters if none exist. This is just a way of initializing the application. And so it's going to use this character repository that I'm going to talk about in just a moment. And if there are any, if it's an empty collection, then it's going to go ahead and add these new characters using this character class. Otherwise, if it's already populated, it'll skip that step, actually that if statement right there. And then it's just going to list all of the characters, return that, and use that as the model for the view. Now, what's interesting here is that although this application used Entity Framework Core and the application DB context for its persistence, you wouldn't know that by looking at the controller. There's nothing here that identifies what is behind this character repository. So you kind of have to, at least at this point, take my word for it that it's using Entity Framework and that application DB context. What the application has done is it's abstracted away the data access mechanism between an interface and named that interface iCharacterRepository. And that follows the repository pattern if you happen to be familiar with software patterns like that. So the constructor essentially requests an instance of the iCharacterRepository, which assigns it then to a private field there. And then that's used to access the characters as necessary throughout the controller, including right there. So this is that pattern of having a field here where you store a reference to an object that was injected into the class. And then that makes it available throughout the rest of the code, whatever code you're running within this controller. Okay, and it's a very common way of using Entity Framework. Okay, so the character repository is going to have all of the features it needs in order to work with the characters. And again, this is somewhat unusual for a sample application. Well, unusual because it's a sample application. Real application, you're probably not going to initialize something like this. You'll be reading a database or things like that. Okay, so that's the entirety of that characters controller that generates that very simple page. Okay, next let's come into here, models, and look at the application DB context. So this code is pretty typical, albeit a very simple example, of an object context for Entity Framework Core. It's just a single collection property, characters, which is defined right there, and it uses this character object. Okay, the rest of the code, pretty minimal Entity Framework, but we can go here and look at character, go to the definition there, and as you can see, there is just a character property. Oops. Okay, and as you can see, there's a couple of constructors. One takes a name to initialize the name property, and the other is a default constructor that doesn't take any parameters. And then down here it just has a couple of properties, an ID, which is a GUID, and a name. Okay, so that's the character model that's used for the application. The next piece we need to look at is here within this interfaces folder and iCharacterRepository. So what this interface does is it defines two methods the controller needs when working with instances of the character class, list all and add. Fairly standard stuff to work with collections of objects. It's very minimal for this very minimal application. It's a read-only kind of application. There'd be a lot more here if we were having to deal with write data, update data, and write data back to the database. Okay, then the next piece is the character repository. So this is what implements that interface that we just looked at. This is the concrete class that the application is going to inject when it's requested, such as within that controller. So again, keeping everything in perspective, we come back over here. I'm injecting an iCharacterRepository, and it's going to be saved to that variable name. And this is the concrete class that that controller is going to receive when that controller is instantiated into memory. Now something interesting here is that notice that this class's constructor also requests injection of the entity framework object context. So what we have in essence is a character controller that is getting that injected, and then an object there that is getting that same context injected as well. So chaining dependency injection like this is pretty common, so that each requested dependency in turn is requesting its own dependencies. And the container is responsible for resolving all of the dependencies in the object graph and returning the fully resolved service. So that's all of the setup of the objects that are needed for the application. The next thing you need to look at is how the app registers the character repository service in order to define that concrete class to be injected when an object of type iCharacterRepository is requested. Now you might think that it would just look for an object that implements that interface. If I go back over here to the characters controller, but there could be multiple objects in the application that implement that iCharacterRepository. So how does the application know what concrete class to instantiate and pass to the constructor here? Well, that happens in Configure Services that we've been talking about. So if we come down here to Startup, and we have Configure Services here, and it's this line of code right here that defines that relationship. So whenever an object is getting an iCharacterRepository injected into it, it's going to use that concrete class, that one that I showed you just a moment ago. Okay, so this is how it defines that as the service to use for this interface. And then keep in mind, this method is also registering the application DB context using the addDB context method, which takes care of registering the service using the addScoped method for a scoped lifetime. Okay, so it's not explicitly using addScoped here within Configure Services, but that's happening within that method right there. Okay, so let's go back to the characters controller. So now you can see what's needed to allow the index method to request the character repository, and it's actually injected into the class here within the constructor. And you also know how it knows how to determine which concrete class to pass and save as a reference within this variable that is then used throughout the application. Actually, this is the variable that's used throughout the application. All right, so hopefully that gives you a little bit more perspective on how all of this works. Now let's talk about service lifetimes as well as registration options. So now keep in mind that there are 3 service lifetimes. I talked about those: transient, scoped, and singleton. This sample application has kind of a cool way to demonstrate the differences. It defines a simple interface called iOperation, which is right there. This represents one or more tasks as an operation that has a unique identifier, which is operation ID right there. And that's a GUID type. Then the code defines 4 interfaces based on iOperation to make clear which lifetime is being requested. And it creates 1 type per lifetime option. Then a single class called operation implements all of these interfaces. So you can see them all listed right there. So ultimately, all requests for any of the interfaces will use this operation class as the concrete class. That's one of the reasons why I like this sample, because it really distills dependency injection down to the essence. And you can see how of these types of operations is added to the dependency injection container in ASP.NET Core. And that again happens within the startup class within Configure Services. So that's this code right here. And this statement right there This iOperation singleton instance service is using a specific instance with a known ID of GUID empty. So it's going to be clear when this type is in use, because its GUID will be all zeros. Okay, the code also registers an operation service right here. And that's defined here within services and operation services. This depends on each of the other operation types, so that it'll be clear within a request whether this service is getting the same instance as the controller or a new one for each operation type. All this service does is expose its dependencies as properties so they can be displayed within the view. And so that's what's actually displayed in the view when I run the application again. Okay, last piece of the puzzle is the operations controller. In this request, each kind of iOperation type in its constructor, as well as an operation service. So those are all being injected into the controller, and it happens right here within the constructor, and it's being saved to these private fields. All right, then the index action method displays all of the controllers and services operation ID values. And it's transmitting them through a view bag with properties for each of the type of lifetime. Okay, so let's see how this all comes together, because it really shows the differences between the different dependency injection lifetimes. So I'll start up the app. Now I want to display this in two different windows. So I'm going to right-click on Operations and select Open the link in a new window. All right, and then that displays that data. See if I can arrange these so we can see them. All right, and then I'll do the same thing, click here, and now I have two windows that show the data. So let's see if I can arrange these so you can see both of them at the same time. There we go. Okay, so first of all, we have two different uses of that object and displaying two different sets of data. And then I have another window which represents a different request for the data. So what's important here is to observe how the operation ID values vary within and between a request. Okay, so transient objects are always different. A new instance is provided to every controller and every service. So I have a transient that starts with 9B3, B27, 2C8, and F36. All of those are different because every time they're injected into an object, you get a different instance of that object. And then scoped objects are the same within a request, but different across requests. So you can see that I have a scope that starts out with 209A and 209A. But down here it starts with D303 and D303. Okay, so these two windows represent two different HTTP requests. And so they use two different versions of the object. But within the request, it's using the same object, so it has the same GUID. Singleton objects are the same for every object in every request, regardless of whether an instance is provided in Configure Services. Okay, so you can see that I have 1B8, 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 and it'll continue to be 1B8 throughout this entire application. So use singletons when you need a single object, single set of state across an entire application.